So this video is about using our trig ratios to find missing sides and missing angles of right triangles. So we have our first triangle just as a warm-up. And so once you find your angle that you want to use, you then find the opposite side and the hypotenuse in this case, or the adjacent. You look to see what we have. And so we have opposite here, and we have hypotenuse. So which trig ratio has O and H in it? That would be sine. So we want to write sine theta is equal to opposite over hypotenuse, and then we just plug everything in. So sine of 20 degrees would be the same as our opposite over our hypotenuse. And now you can see that we have x. So we do a quick little cross multiply. So this is x sine of 20 degrees equals 3. And then we divide to solve for our x. So we get x equals 3 over sine of 20 degrees. Now you can also see that all we really did was replace the sine and the x. We just swapped them. So that's another way of looking at it. And so now we just plug that into our calculator. Make sure your mode is in degrees. Perfect. And so we are going to plug in 3 divided by sine of 20. So 3 divided by sine of 20 degrees. Hit enter. And there we go. It's 8.771. And that is our measure. So how long is that hypotenuse? 8.771. All right, let's try an angle now. So same idea. We have some angle here. And that's our hypotenuse. That's our opposite. And that's our adjacent. So which one has O and A in it? That's tangent. So tangent theta is opposite over adjacent, and then we plug it in. So tangent theta is equal to 7 over 3, and then now we use our arc tangent or inverse tangent, and this will help us find our angle. So we pull open our calculator and we go second tangent, 7 divided by 3. And now it's in degrees, so it will give us the degree measure. If you wanted the radian, you would change your mode to radians, but it's 66.8 degrees. And that is our theta. So that's it. You're either finding a side using the correct trig ratio for it, or an angle using the trig ratio for it. So let's try an application. So a 20-foot ladder is leaned against a building. So the first thing we want to do is draw a picture. So we have some building, put a door on it, and we have a ladder leaned against it. And then those both would be on the same ground. So we're assuming that that building is perfectly perpendicular, right? We know it's 90. Okay, so it says if the base of the ladder is 6 feet from the base of the building. So we know that that would be 6 feet from there to there. So we have one side. What is the angle of elevation of the ladder? So we also know that the ladder is 20 feet long. So it says what is the angle of elevation? Angle of elevation is always with the horizontal, like that. So that is our theta. So if we mark everything, this is opposite, this is adjacent, and this is hypotenuse. Which one has A and H in it? Exactly, cosine. So that is our trig ratio, right? Cosine theta is equal to adjacent over hypotenuse, to capital A, capital H. And so we put cosine theta is equal to 6 over 20. And this is an angle one. So we say theta equals inverse cosine of 6 over 20. And you notice I'm not even reducing. We just plug it in the calculator. So second cosine 6 divided by 20. Close it. Hit enter. And it says 72.54 degrees. So 72.54 degrees is our angle of elevation. So this ladder, if it's 20 feet long and it's 6 feet from the base, the angle it makes with the building is 72.5. Not with the building, with the ground is 72.54. You could actually find the angle as well just by subtracting 90 from it. Remember, these two angles add up to 90 because that's 90. They all add up to 180. So we would know that this one is around 17.46 degrees. All right, thank you.